Hey everybody, welcome back to V101 TV. I am Tim Smith at tsmith_co on Twitter. Be sure to subscribe to this channel for more videos. Last time we went ahead and deployed the VCSA, the vCenter appliance, into our cluster and configured the networking. Today we're going to go ahead and configure vSAN. Let's go ahead and take a look at one of our hosts here. You can see on the virtual switch we've got multiple vSAN port groups with VM kernel interfaces on them. In this scenario, there are one NIC per VMK. Now, you can use multiple VM kernel interfaces for vSAN, but they need to be on a separate subnet. Obviously, best case scenario is using 10 gig where you don't need multiple VM kernels, and you can just use network load balancing or particular failover. But let's go ahead and configure our cluster here. So click on your cluster and go to Configure tab. And we're going to go to General under vSAN and click Configure there. We can claim our disks automatically or manually. I'm going to choose manual just so you can see what's happening. Now, deduplication and compression is only for an all-flash version of vSAN. In my case, we're using a hybrid, so I've got spindles along with my cache disk. And fault domains and stretch clusters. So we've got a couple options. A 2-host, we can do a stretch cluster, which would be a vSAN cluster that stretches across 2 sites, and then a fault domain. Fault domains are what you would set up if you want to be able to withstand like a rack failure. One rack would be an individual fault domain. In this case, I'm not going to do any of those for my lab. So it's going to verify our networking here. You can see that it verifies that all 3 hosts are set up properly, VM kernel interfaces are set up, tagged for vSAN traffic, and all are on separate subnets. So now we're going to go ahead and claim disks. It's going to go look at our servers and see what disks are available to be claimed. And here's where we can go ahead and manually select what we're going to do. Now in the automatic mode, it would select these for us and we wouldn't need to do a thing. But you can see I've got 8 hard disk drives there and flash. 1 per server, so I've got 3 cache disks listed here. And then I've got a total of 9 hard disk drives, 3 per server. Thankfully, I don't have to select each one of these individual. We can select multiples, so let's go ahead and do that now. We'll go ahead and click on the claim for cache disk. These 2 buttons here allow you to mark your drive as flash or hard disk drive if for some reason it didn't get recognized properly. But mine did, so let's claim these flash disks for our cache tier. And let's go ahead and select these hard disk drives for our capacity tier. It's going to go ahead and select all of them for every server. And we'll click Next. And just a summary of our settings here, the total capacity and the total cache. And that's about it. So at this point, we're configuring the cluster and we're adding all of our disks into the vSAN data store, getting them all claimed and set up. Now remember, there's no VM FS on vSAN. It's very similar to virtual volumes where it's directly onto the block. So you can see we've got all 12 disks here and we're on version 3.0 for our disk format since we're on the latest version. We can give our cluster internet activity. This allows it to go out and check the hardware compatibility list. That way we can make sure that we're on the proper firmware, our cards are supported. We also have this iSCSI target service. Now this allows you to present your vSAN data store as an iSCSI storage to some of your physical servers out there. At this point, it is not supported to present that iSCSI storage to virtual machines running in vSAN. Let's go to our disk management here, and you can see our disk groups. Each server has its own disk group, which contains 1 cache disk and 3 capacity disks in our case. You can have multiple disk groups per server if you have servers that are able to hold a larger amount of drives. Fault domain and stretch clusters, we don't have one set up. In our environment, we can withstand a single host failure. Now remember, in a 3-host scenario, which is supported, you can withstand 1 host failure, but after that, you're stuck. So in a maintenance scenario, you'll want to be very careful. The Health and Performance tab here allows you to view the health status of vSAN. It's going to go ahead and install a VIB on each host, which allows it to monitor the health of the disks, the vSAN environment, cache, everything that's going on here. You can see the HCL database hasn't been updated yet since we haven't configured anything yet to be updated. And we've got the performance service, which is turned off here by default. I'm going to go ahead and turn that on so we can start collecting some performance metrics for our vSAN data stores. Now let's go over to monitor. We have a virtual SAN tab, and here's where we can look at the actual health. We can look at our physical disk health, see how much is used in the data store right now, how much is reserved. Now you can see here I've got a failed under hardware compatibility and under a warning under performance. It's a home lab. I don't have equipment that is up to date on the HCL. My physical HBA was on the HCL for 5.5, but unfortunately not for 6.0 and above. So let's go ahead and look at the capacity here. So here you can see I've got 2.43 terabytes of free capacity. If I had an all-flash setup here, you would be able to see the deduplication and compression savings. Now remember, with the default virtual SAN storage policy, everything's written basically as a RAID 1. So if you have a 50 gig VMDK given to a virtual machine, it's going to take up 100 gig if it is completely full. Let's go ahead and take a look at those policies though to see what some of the other options are. So storage policies, VM storage policies, and we're going to select the virtual SAN default storage policy. And let's go over to the edit settings here to see what's going on. So by default, we can tolerate a single failure, and our individual disks have a single stripe. Now, if we wanted a little bit better read performance or write performance for sequential writes, we can stripe across the multiple disks. I've got 3 disks per server. Forced provisioning is basically allows you to use the space available when the policy is not being applied properly. So if I were to drop down to a 2-host scenario, it wouldn't allow me to provision a new VM because it wouldn't be able to meet the storage requirements I've set. Object reservation, so I can reserve a certain amount for the virtual disks, and flash read cache. I can dedicate a certain amount of the cache to particular VMs in the storage policy. So it's pretty flexible, and you can have multiple storage policies set up that encompass that single vSAN data store. So if I wanted to set up a policy that was, let's say, gold, which allowed it to stretch across 3 spindles, then I could certainly do that. Or I could just stick with the default and have all of my VMs there. So lots of customization here, lots of options, and that's about it. As you can see, configuring vSAN is really quite simple and can be done in easily less than 10 minutes. Be sure to subscribe to the channel and catch me on the next video.